Hello viewers, welcome to this tutorial on Arduino Mega Board programming and simulation. So in this tutorial, we will discuss about how to program a microcontroller, how to write a program in embedded C language, how to compile it, how to convert it into a hexadecimal file, then how to import it onto a simulation environment. So in the earlier tutorial, I have discussed about the methodology of importing your program into the program memory of your Arduino Mega Board. So here we will be making use of two softwares, Arduino IDE for creating our embedded C program and converting the embedded C program into a object file or an hexadecimal file. So once this file is created using either a bootloader in the Arduino Mega Board or through an external programmer, we will import this file into the program memory of your Arduino Mega Board. Then we can check the logic of our program, whether it is working properly or not, by changing the input values and by checking the output results. So we will discuss about this methodology in detail. So first, let me start with creating a program in an Arduino environment. So you can download the Arduino IDE from arduino.cc website. So there they have provided the software for different platforms like Windows environment, Linux environment and Mac OS environment. So I have already installed the Arduino IDE. So I am going to open this Arduino IDE. When you open the Arduino IDE, so you will get the sketch document. So this sketch document will be used for writing our embedded C program. So by default, when you open the Arduino IDE, you will get two functions, void setup and void loop. So we will come to this in a moment. So before that, we need to know about some configuration which we need to carry out with this Arduino IDE. So as you all know that IDE supports many boards like Arduino Uno, Arduino Melano, Arduino Mega Boards, Espera, Mini, etc. So we need to specify for which board we are going to write a program. So that can be configured using this sketch window. In sketch window, you can go to tools. In tools, you will have board information. So as you can see, in the board, you have a very large number of list of boards available like Arduino Uno, Melano, Nano, Mega, Leonardo, Micro, Exploro, Mino. So like that it goes on. So we need to select the right board. So since we are working with Arduino Mega Board, we need to select the Arduino Mega Board. So once this is done, one more step you need to carry out, which is the port configuration. So whenever you connect your Arduino Mega Board to your computer, you need to select the corresponding COM port number. So in order to do that, again you go to tools. In that you have a port option. So when your Arduino Mega Board is connected to a computer, you will find a COM port available here. So then you have to select the corresponding COM port. So once this setting is done, we can start with our programming part. So as we all know that when I open the sketch window, we will have two functions, void setup and void loop. So what is the importance of this functions? So this void setup is usually used for the configuration of your microcontroller. As I said in my earlier tutorial, so whenever I want to use any microcontroller, we can't use it directly. First, we need to do the configuration part. Once the configuration is carried out, then we can make use of the peripherals as well as the features of our microcontroller. So for each and every application, first we need to do the configuration part. So this configuration can be done only once. So that section of the code can be put up in this void setup region. So mostly the configuration data of our microcontroller comes into this void setup region, which runs only once during the execution time of our program. Whereas the actual logic of our program resides in the loop part. So which needs to run multiple number of times. So technically speaking, this loop function will run infinite number of times. So whatever logic we want our embedded system to work, that we can put into this loop function. So as you know, this setup and loop, it has both input arguments and output arguments. So we can send some parameter into this function, and also we can get out some parameter from this function. So right now we have specified it as void for both the functions, which indicates that we are not going to have any return arguments from this function. Same way, we are not going to provide any input argument since these brackets are empty. So we can also specify here void. Void means no parameter is going to go into our input functions like setup and void. So if some parameter needs to be passed onto this function setup and loop, we can specify depending upon the data type. So if I want to pass on an integer data, we can put int. If I want to pass on something like a character data, I can put character here. So that our function takes some input parameters, and then after performing the code, it will return certain parameters. So here in this case, it will be void. So for this program, we are not going to have any input parameters and output parameters. So I am going to make this as a void. Right. So in this section, we are going to put our program. So before writing any program, it is better to have an idea about the hardware part. So we need to know where we are going to connect our peripherals and what is the logic behind our program. So which will help us to write the program in a better function. So first we will dive on to creating our hardware circuit using Proteus 8 simulator. So I am going to open Proteus 8 simulator. Once I open this, you will get this window. So the first step in creating a project is you have to create a new project. So go to new project. So here I am going to define a location where I am going to put all my project files. So I am going to take a location in downloads. In work, here I will create a folder called as Proteus. So in Proteus, I am going to put all my project files. And for this application, I am going to do a simple LED interface with Arduino Mega Board. So I am going to name the project as LED. And the project extension is .pdsprj. Two steps we have done here. One is selecting a location for storing our project files. Another one is giving a name for our project. So once that is done, click next. Then first we have to select the template where we are going to build our hardware circuit. So I am going to create a template which is default in nature, default size. So if I want to change the size, we can very well do with either selecting a A0 size, A1 size in portrait or landscape format. So there are different sizes are available. For this example, I am going to take a default size. So then I can click next. Then we can also use this Proteus software for creating the PCB layout. So right now we are not going to do any PCB layout. So I specify it as do not create a PCB layout. Then press next. Then we are not going to use any firmware related to either 8051 or some other microcontroller. So I am going to leave it as it is. No firmware project. Click next. So once you do this, you can see the summary part. You see that schematic is only having a highlighter. Other layout as well as firmware, we are not going to use in our project. So once this is done, you click finish. So once you click finish, you will get this location where we need to build our circuit. So here you see a blue box. So within this blue box, we need to build our circuit. In order to build our circuit, the first thing which we need to do is we need to pick the components from our database. So in order to pick the components for our database, what we can do is we can go to this P button. P is for pick devices. Click on this, you will get another window. So here I am going to type Arduino So once I type Arduino, you can find lot of Arduino versions like Arduino Mega 1280, Arduino Mega 2560, Arduino Uno. So we are working with Arduino Mega 2560. So I'm going to select on that. So you can see the schematic of your Arduino Mega Board. So once I click on this, right now you see in our project we don't have any items right now picked up. So when I double click on this, the item will get added in this list. So then we are going to do a simple LED interface. So I need a LED. So I type LED in this keyword location, and you can find lot of LEDs, and I'm going to use an animated version so that we can see the output physically. So I'm going to select an yellow LED. So here you can see LED yellow animated LED model. So when I double click on it, it will get added to our list. So these are the two items right now required for building our circuit. So I am done with selecting the components. So I press OK and come on. So now we have selected the component. The next step is we need to build our circuit. For building the circuit, I am going to click on this Arduino Mega. It will show the schematic here. Then I can move it into this working window and I can place it wherever I want in this blue screen. So I am going to place it here. So you can see this is a Arduino Mega 2560 board. Here you have an IC and the pins are defined here. So for example, you can see the the address lines are defined in this location for interfacing your external memory. So your PWM lines for communication, UART, we have 4 UART communications. So all these pins are defined here. Analog inputs, digital inputs, so everything are defined in this Arduino Mega Board module. So now what I am going to do is I am going to connect the LED which I have selected into a pin number 13 of our Arduino Mega Board. So I am going to, for simplicity, I am going to rotate this device. So right now you can see it vertically. I want it to make it as horizontally. So I can use this function to rotate the component. So I am going to do an anti-clockwise rotation of 90 degrees. Then I am going to use the component in our schematic. So here I place our LED. So LED is a simple 2-terminal device with anode and a cathode. So I am going to connect the anode to the pin number 13 of Arduino Mega Board, and cathode I need to connect it to the ground. So in order to select a ground, I can go to this left hand side palette, and here I have the terminals mode. So in terminals mode, if I click on it, you can see different options like power and ground. We need to make use of ground. So I select the ground and I place it onto the schematic. Then I can connect the cathode of the LED to the ground terminal. So this completes our hardware part. So in order for our LED to glow, we need to make this pin 13 to go to high. Once it goes to high, the LED will start glowing. If this pin number 13 goes to low, then the LED will be in off state. So that is the logic which we are going to write in our embedded C program. So right now we completed our circuit. We can save this circuit. So I can go to the save button and I can save the project. So you can see right now the project has been saved with the name LED. So now we are done with the hardware circuit. Now we can go and build our embedded C program. So I open Arduino. So here we have already discussed about this setup function and loop function. As I already mentioned, this setup function is used for configuration. So here for this application, what we are going to do, we need to define this pin number 13 as a output pin that we need to define. So because each GPIO pin it can be configured as an input pin or an output pin. Since we have connected an LED, it's an output device. So we need to configure this pin as an output pin before making use of that pin. So the first step is in void setup, we try to put pin mode is a function which used for configuring your GPIO pins. So pin mode, I am setting the pin number to be 13, and I want the pin to be in an output mode. So we define it as output. Then each and every statement in an embedded C program, it ends with a semicolon. So that completes our configuration part, because we are going to connect just one LED to pin number 13 of your Arduino Mega Board. So that completes the configuration. Now we are going to write the logic for our program. So I want my LED to blink for every 1 second. So in order to do that, we go to the loop function. In loop function, the function which we use is digital write. Digital write, in brackets, I specify the pin number and I want this pin to go to height. And the statement ends with a semicolon. So this line, when it gets executed, since our Arduino Mega Board is connected with a 16 MHz crystal oscillator, the execution will be very fast. It will be in terms of a microsecond order. So in order for our visualization of the output, this pin number 13 should be high for certain time period. So in order to maintain this value for certain time period, we need to use a delay function. Delay of 1000, which indicates a millisecond order, 1000 millisecond, which means 1 second. So for 1 second, the value of I in pin number 13 will be retained. So after this 1 second, I am going to switch off my LED by again using the same function, digital write, pin number 13. Now I am going to set it to low, which means the LED will go to off state. Again, I want to retain this value for 1 second, so I use a delay function of 1000 millisecond. Once I complete this, since this statements are in the loop function, as I said earlier, the loop function will get executed infinite number of times. So the LED will go from on to off, on to off, on to off, again and again. So that completes our code. So once I completed the program, we need to save this program. So for saving, you can go to File, Save. So it will ask for a location. So you can pick a location. I'm going to go to Download, Work. So here I will create a folder of Arduino. So in the Arduino folder, I'm going to put the program. So program, it should be saved with an extension of .c. So I'm going to give a file name, led.c. So the program is saved with an extension of .c. So once I save it, we are done with our program. We can check whether our program has any errors or not. So that can be done using the verify button here, the tick mark here. When I click on this, you can see right now it is compiling the sketch. Once the compilation is done, it will show me the results. So right now there are no errors there in the program. So if some errors are there, how it can be identified? For example, intentionally I am removing this semicolon. So again I will try to do the verify part. So when I do this process, you can see expected semicolon before the delay function. So it shows here we require a semicolon. So we can add and again we can run the program. So right now the program has no errors. So we will go to the location and see. When I go to the location, you can see here in Arduino we have the project folder location. In that you have only the Arduino file. So this file I can't put it onto our microcontroller. So we need to have a hexadecimal file. So in order to do that, what we need to do is again go to Arduino. In Arduino environment, go to Sketch. In Sketch, you have an option of export compiled binary. So this operation will convert your high-level language program to a binary file or a hexadecimal file. So I am going to export the compiled binary for this program. So once I do that, again it will compile and it will convert and it will transfer to the same location. When I go to that location, you can find right now I have created the X file. Here you can see the type of file, X file. When I try to open this X file using a notepad, you can see the opcode part of your program. So whatever we have written in the C language, it has been converted into a hexadecimal format. So you can look at this format. So it starts with an address, the number of data bytes, how many data bytes are there, then checksum errors. So the format has each line has a particular format. So I'm not going to go into the details of this format. So now we have created our hexadecimal file. So this we can import into our Proteus simulation environment. So now I open Proteus environment. So we are ready with our hardware. We are ready with our hexadecimal file. Now I want to import this hexadecimal file into this hardware. So how to do it? Right click on this Arduino Mega Board. You can go to edit properties. In edit properties, you have an option of program file. So in program file, you browse to that location. I have the data in my downloads folder. So go to this location, go to this Arduino LED. So I need to select the X file. So the X file I am going to select, which means I am putting the X file into the Arduino Mega Board. So here you can see right now the X file has been imported. Press OK. So now we have done with importing our X file into the Arduino Mega Board. Now we have to check whether our program is working properly or not. How to do that? In the Proteus environment, on the left side bottom, you have this play button. So this is for running the simulation part. So when I press this, you can see right now the LED starts blinking. For every 1 second, it starts to be in on state, and then for next 1 second, it will be in off state. So that is how we can check whether our embedded C program which we have written is working properly or not. So before building an hardware, it is always better to check our code using the simulator. Then we can avoid some real-time issues. So we can check for all the possible combination of inputs and check whether our code is working properly or not. So in this tutorial, I have talked about how to write an embedded C program in Arduino IDE environment, and how to create a hexadecimal file out of it, and how to build a circuit in a Proteus simulator, and how to import this X file into the Proteus simulator and check for the operation of our program. In order to stop this simulation, you press this stop button. So in the upcoming videos, we will try to look at more number of applications which we will do with this Arduino IDE environment and Proteus 8 simulation. Thanks for watching. Please subscribe for more technical learning. Thank you.